welcome back. So what we're looking at today is lesson 5, solving any linear equation. So more with our solving, more practice solving and understanding the balances and just how we rearrange things to be able to take and solve. So let's go ahead and jump right in. Now, what you're seeing here, I know does not look like anything that is in your workbook, but this is the trading moves. So this is the second part. So these are the 4 different cards. Obviously, I'm not, you're not going back and forth with a partner taking turns solving, but we are going to go through each of these and solve them so you can see and have a little more practice seeing how these get solved. So for the first one, we have negative 6x minus 7 equals 4x minus 2. So the first thing we need to do is get our variables to the same side and our constants to the other side. So I'm going to add 6x. Now, like I've said before, from that starting equation, there were 4 different ways to start the problem. Each would result in the exact same solution. But I started by getting rid of that negative 6x. I wanted to move it, take care of it. So now we have 6x is canceled because negative plus positive cancels out. And then 4x plus 6x gives me 10x. So I have negative 7 equals 10x minus 2. So now my x's are combined. Now I need to combine my constants. So I'm going to move the 2 over to join the 7. Never bring everything all to the same side. We don't want to move both the negative 6x and the negative 7 to the other side because then it just equals 0 and then we just have to move it back so then we can divide. So don't do that, okay? Because if you have it all on the same side and then you try to divide, it's going to result in the wrong sign on your answer. So you might end up with a positive when it should be a negative or vice versa. So be super careful with that. So negative 7 plus 2 is going to give us a negative 5 equals 10x. And then we divide by 10. So we end up with a negative 1/2 equals x. There's our answer. All right, on B. So on B, we have a couple different ways we could start this. First would be to multiply by a half and get rid of that. So use the distributive property. Or we can take and multiply by 2 to both sides and eliminate having a fraction. So I'm going to eliminate having a fraction because I don't necessarily like having to deal with fractions from the get-go. It makes it more confusing and you have to think about it a little more. So it just makes it easier. So now we have 7x minus 6 equals 6 times 2 is 12x minus 10 times 2 is 20. And so now from this point here, we have 4 different ways to start once again. So I'm going to start by subtracting 7x. That cancels. So we have negative 6 equals 12 minus 7 is going to give us 5x minus 20. We're going to add the 20 to both sides. So negative 6 plus 20 is going to give us a negative, it's going to give us a positive 14, which will equal 5x. And then last but not least, we have to take 14 and divide it by 5. So we end up with 2.8 equals x. And having decimals for solutions is a very possible and probable thing that you will come across. So don't think just because you've got a decimal that means you have the wrong answer. In some cases, obviously it could, but in other cases, just like this one, we have the correct answer, but we have a decimal. So that's completely possible, okay? All right, C, we have 1/2 x plus 7 equals x plus 13. So for this one, I'm going to start by subtracting subtracting the 7. And so I have 1/2 x equals x. 13 minus 7 is 6. Now I'm going to subtract x. And this is really a 1x. So if it helps you to have that 1 in there to remember what the coefficient is, so you don't just drop the x entirely. I've had people do that in the past. by all means include the 1 in there. So this cancels out, so this side's left with 6. Now, 1/2 minus 1 is going to give us a negative 1/2 x. So then you can either think of it as dividing by a negative half or multiplying by -2. It works out the same in the end either way. So times -2 times -2, those cancel. So we're left with x equals -12. So like I said, be very, very careful when you have the fractions. Sometimes it's not possible to eliminate them. So you have to be super careful when you're solving to make sure that you solve accurately. All right, this last part. So we have 2 times x plus 7 equals -4x plus 14. So I'm going to go ahead and divide the 2 away so I don't have to distribute it. So I'm going to have x plus 7 equals -4 divided by 2 is -2x. 14 divided by 2 is 7. All right, so then I'm going to subtract the 7. That goes away, so I end up with x equals -2x because it also canceled there. Now, subtract x. So I'm going to end up with 0 equals -3x. We divide by 3, so we just end up with 0 equals x. Now, at this step here, well, quite frankly, at this step right here, when I had x plus 7 equals -2x plus 7, because both of them were a plus 7, and then we had a variable that wasn't going to cancel, I knew right away that this was going to be x equals 0 because I knew the constants were going to cancel out, so we'd be left with a variable equals a variable. The only way that a variable without a coefficient can equal a variable with one is when x is 0. So if you can recognize that, then by all means, you can jump right on down to x equals 0 if you can recognize it. If not, that's perfectly okay, and finish solving it out just like we did here. Okay? All right, so these are a little more complex, that's for sure. We've got a lot of things going on in here. We've got fractions that sometimes we can't get rid of. We've got distributing. We've got problems where constants disappear, all sorts of stuff. So your keyword for this lesson is complex. Complex. All right. The last part of this lesson, a puzzling puzzle. Tyler says he invented a number puzzle. He asks Claire to pick a number and then asks her to do the following. Triple the number. So we don't know what Claire's number is. So we know, let's say Claire's number is x. Well, based on what he's saying, she needs to triple it. So 3x. Next, it tells us to subtract 7. So -7. Double the result. So that means we need to put parentheses around all this to double what the 3x minus 7 would be. Then we're going to subtract 22. And then last but not least is take all of that and divide by 6 or multiply by 1/6. Claire says she now has a -3. Tyler says her original number must have been a 3. How did Tyler know that? Explain or show your reasoning. Be prepared to share. So, obviously there's a lot going on in this expression, but can we simplify it? Yes, of course we can. So, start from the inside. We start in the innermost parentheses. Is there anything we can simplify there? No, there's nothing. We can't add or subtract these. There's no multiplying to do in there. But we can take this 2 and multiply it to both of these. So we're going to have 1/6 times 6x minus 14 minus 22. So now, can we take and do anything with the -14 and the -22? Yes, we can. So we're going to have -6, or sorry, not -6. We're going to have 1/6 times 6x minus, so we have a -14 minus 22, so it's going to go further negative and be minus 36. So now we just multiply by 1/6, which is the same as dividing by 6. 6x divided by 6 is x. 36 divided by 6 is 6. So all of this simplifies down to just x minus 6. So How did he know that her original number must have been a 3? Well, set it equal to -3, add 6, add 6, x equals 3. So all he had to do was figure out the x minus 6 part. What number minus 6 would give -3? Well, that'd be +3. So that's how he knew. He knew the simplified version of this. He knew what the equation was and then the simplified expression that came from that, so that he could always know what the original number would be pretty easily. So, like I said, this equation especially is a very complex equation. We've got double set of parentheses, we've got multiplying, we've got dividing, subtracting, all sorts of stuff going on. So some of these equations can be very complex, so you really have to think about them sometimes. But as long as you follow order of operations and using keeping both sides balanced and equal, like we did down here, then you will be just fine. If you guys have any questions, though, feel free to ask. Bye.